Rate of reaction is a very important topic in chemistry. So in this video I'm going to talk about these points. First, what is rate of reaction and how you can measure it. How you can plot the graph to show the reaction happening. And what is the collision theory? The factor which affect the rate of reaction. So let's start with the first point. If I will say what is rate of reaction? What is the definition of rate of reaction? Rate of reaction will tell about how fast or slow a reaction is happening. So this is how I tell to my student. Rate means change with respect to time. Okay, respect to time. So with the time the reaction is happening fast or slow. Now what is reaction? Reaction means, suppose if I'm mixing the two chemicals and I'm seeing one product Z. This side is called reactant and this side we say product. So how fast your reactant disappear and how fast product appear, right? So this will tell you about how the reaction process. So we can show the rate of reaction in two ways. You can show how the reactant mass is decreasing or how fast your product is increasing, your product is forming. So let's take one example. Suppose I want to show that, so in this example, suppose this is the calcium carbonate react with hydrochloric acid, it will give you calcium chloride, water and CO2. So if I'll ask you how to draw the rate of reaction for this kind of reaction, so you can measure, as I told you, reactant rate by two methods. I can also take the mass of the reactant and figure out how much it is decreasing or increasing, or you can measure the CO2 gas as evolved, how much it is increased. So how to measure the mass of the reactants? So this is what you can do. So you can measure exactly how much was the initial marble chips and hydrochloric acid, and as you can see from the graph that mass of the reactant with the time it is decreasing. So initially it will start with the original amount, but as the time proceed the reactant mass will decrease. And here we have the graph. So this is the reactant mass. What about the other way around? It means we can also measure with the measuring the amount of the gas produced. So for the gas produced, you can use this gas syringe where you can collect the gas and figure out with the time how much gas is produced. So this is how the graph will look, because here the product is forming, so you will see the graph is increasing with the time, right? So this is our graph. So initially, as you can see from point 1, the gradient is more. It means what? It means initially the gradient is high. It means initially this part of the graph the reaction rate is very high. So whenever the graph, we always talk about the gradient. What is gradient? This is also called slope. Slope means how the plane is inclined from the horizontal. So if this is the theta, this is more gradient than this one, right? So if this is the theta 1 is greater than the theta 2, it means this is higher gradient than this. So if you look in this graph, at point 1 gradient is larger than point 2, and at point 3 the gradient is 0. It means the reaction is stopped. So this is how you can talk in terms of rate of reaction in the graph. So overall graph, what we have learned, that we can plot the rate of reaction in two ways. You can plot the rate of reaction either increasing of the product like graph number 1, or you can also show the rate of reaction in terms of reactant where the mass of reactant is increasing. Now here we have to mention about the 2 points. The first point, since the mass of product is increasing, gradient of graph will be always positive. So here the gradient will always show the positive result. It means what? It is increasing with the time. However, if you look the reactant, its mass is decreasing, that's why you will always see the negative gradient. So negative gradient of the graph will be in the reactant and the positive gradient will be in the product side. So I hope this is clear now. Now let's talk about the other part, how you can define rate of reaction is happening or not. So the very classic theory given by the collision theory. As the name suggests, collision means how the particles are colliding each other, right? So if you link the particles, So since these two molecules are going to show you only reaction when they are colliding, as you can see in this diagram, that these molecules are colliding each other and finally they will give you the products. So collision theory said that when a chemical reaction occurs between the particles, collision is said to effective collision. So effective means if they are colliding, you should see the products and they should overcome the minimum energy required for the reaction, which is called activation energy. What is activation energy? Activation energy is defined as the minimum amount of energy which require a reaction to occur. Now in the rate of reaction you will see all these parameters, whatever will affect the rate of reaction, they all dependent on whether effective collision is happening or not. If effective collision will happen between particles, you will see the products. So what are the factors which affect the rate of effective collision? So the parameter which affect the rate of collision: temperature, concentration, particle size, pressure and catalyst. Let's talk about each of them. So how temperature affect the effective collision or rate of reaction? What do you think? So whenever the temperature will increase, what we know that particles start moving a lot. Why? Because it has more kinetic energy. It means they can vibrate faster, and since they can vibrate faster, they can collide more number of particles, and that's why we will see rate of reaction will increase. And you can do the reverse. If the temperature will decrease, the particles will just sitting at position, so you will not see the effective collision, and so rate of reaction will decrease. So what is the second point? Say at higher temperature, more reactant particles possess energy that is greater than equal to activation energy. So obviously activation is the minimum energy required for the reaction, but if you are increasing the temperature, you will see the frequency of collision is increasing. So that's why we will see more rate of reaction. So suppose if I need to plot the graph, how the graph will look, rate of reaction and the temperature. So we can plot the graph something like this, that look, when the time is increasing, when the temperature increases, as you can see in this graph, when the temperature is increasing, as you can see here, rate of reaction is increasing. How can you tell that? Because it is taking shorter time. So for this temperature 60 degrees Celsius, reaction is just happening in just around 15 seconds, right? So always remember the rate of reaction is inversely proportional to time taken to complete the reaction, right? Shorter the time, rate of reaction is higher because you are seeing the product within few seconds. Longer the time, slower the rate of reaction. So I can also represent rate of reaction by 1 by t. So 1 by t is what? It is just rate of reaction to show rate of reaction. Here as you can see the same graph in this way, that when the temperature increase, rate of reaction is increasing because the time is taking shorter. So till now what we discussed how about the temperature is affecting the rate of reaction. Now what about the next part? Next part we are going to look about how the concentration affect the rate of reaction. Concentration means what? Concentration means the more number of particles in per unit volume. So again, if you have a two scenario, one scenario this is only 3 particles, and one scenario you have around 8 particles, in which condition they are chance that they will collide more. You will see obviously part B, right? So what is happening when you increase the concentration, they are colliding more, that's why rate of reaction will increase. So you can design an experiment in which you can put like in the same equation what I have given you in the previous, that you can use the limestone plus HCl, it will give you calcium chloride plus CO2 plus H2O, and then you can just balance it. Here what you can do, you can change the concentration of HCl. Suppose you can use 0.05 millimole HCl, you can use 1 millimole, and try how the rate of reaction is going to affect, how you can interpret the graph. So let's see the graph in this kind of equation. As you can see here, when you are using different concentration of HCl, you will see the different gradient. So which graph here represent the higher concentration of HCl? So you can guess based on gradient. So as you can see here, this graph number 1 has higher gradient, more theta, it means this one is highest concentration compared to graph number 2 compared to graph 3. So graph 3 we have used the lower concentration of HCl. However, this is not changed. Why? Because we didn't change the another reactant, which is the limestone. We are just modifying the HCl. So obviously the final product is going to be give you the same result, like same CO2 is going to produce, because you didn't change the other parameter. Now this is clear. So here we can assume that suppose you have one cube which side is around 2 centimeter cube. This is around 2 centimeter cube. So what will be the volume? Volume will be around 2 to the power cube, which is 8 centimeter cube. So let's break it down into 8 small cube which have a side 1 centimeter. So here what we are doing, that each cube here represent, so here A is equal to 1 centimeter. So what I make sure that they are occupying the same volume. Why? Because when you have 8 into 1 ka whole cube, it is 8. So basically volume is same. Now let's calculate about area. What about area, surface area here? Here about 6, you know what is the area of cube? 6 A square. It means 6 to the power 2 ka square means 24 centimeter square. And what about here? Every cube we can write it down, it is 6 ka whole square means 6. But how many cube have? 1 2 3 4 5 6 7 8. It means the total is 48 centimeter square. Okay, so as you can see here, that even though the volume is same, but when we split this cube into 8 small pieces, the surface area is large. That's why here the reactant can react more to the other particles, because every other area, so in this part is not exposed, the inside part is not exposed, but here all other parts, as you can see here, exposed. So I hope you're understanding what I mean to expose. Like in this, the inner part is not exposed, only you can see the reactant can collide with this side, this side, this side, but here every part is exposed, so they can react fast. So what I want to say that in the large reactant particles, some part is hidden, but when you break down into smaller piece, every part is exposed. That's why you will see the reaction happening to all the around. So obviously when you see something like a big stone and when you see the powder size, reactant will happen very fast in the powder size. So how to plot the graph? What we can do, again you measure the reactant mass in the start and take the two scenario. One scenario will take a limestone, which is the calcium carbonate, a big particles. So we will take big particles, and in another scenario we will take a small particles, okay, or powdered form. Now how the graph will look? You can guess that in a small particle the rate of reaction will be very high. So in this graph, can you predict which one is the powder form of marble chips? Yes. So remember, this is the graph showing the reactant mass. So reactant mass will show you negative gradient. It means it is decreasing with the time. So decrease is happening very fast in the powdered marble chips than the lump of marble chips. So here rate of reaction is happening fast. So you'll see more amount of CO2 produced when they are in powdered form. Now what about the next part we are going to learn? Next part is about the effect of pressure. So you can guess that when the pressure apply, the gaseous particle come closer, and that's why the chances of collision is going to be increased. So here when you increase the pressure, you can see here particles will come closer. So remember, this you will see only in the gaseous reactant. But what about solid and liquid? So solid liquid, there will be no much effect. Why? Because there is no space in between them. So in solid particles already the molecules are very tight, so even though you apply the pressure, you're not going to see the effect. So very important point, this is only for the gaseous reactant. So now let's talk about the next part, which is very important, the catalyst. How the catalyst affect the rate of reaction. So what is catalyst? Catalyst is a chemicals which can affect the rate of chemical reaction without being chemically changed in the end of reaction. So there are some property which you are going to learn. They increase the rate of reaction but not the yield. It means you will not see that 100 become 200, but obviously reaction will be fast, means less time. they are not used up in the reaction, they are very selective. Means you can see that one particular catalyst used for one reaction, other it cannot work, and if there's some impurities it can poison them. Very important, they provide an alternative path for lower activation energy for the reaction. So let's talk about the graph, which is very important in the reaction. So here in the first part it is uncatalyzed reaction, means we have not used a catalyst, but here the another reaction is catalyzed reaction. How you can guess that? You can guess from the activation energy. So here see, this uncatalyzed reaction has to cross this much energy to occur the reaction. However, the catalyzed reaction is just going to perform in very less energy, so it will happen very fast. Now let's practice some of the question. So look at the question. What is saying? An experiment was carried out to investigate the effect of concentration. What we want to show? The effect of concentration on the rate of reaction between the sodium carbonate and hydrochloric acid. The graph of the volume CO2 is plotted against which graph 1 and 2 shows what? First, faster rate of reaction. So faster rate of reaction means what? We need to find it down which have highest gradient. So here, as you can see here, in which you see highest gradient, it is in graph number 1. So option number 1. And next part they are saying that which graph show the lower concentration of the reactant. So lower concentration gradient means it is happening slow, so it is point number 2. So I hope this part is clear. Let me know in comment section if you have any doubt, and thank you for watching. Share with your friends so that they can also get benefit from this session. Thank you.